respected professors and honorable interview panel members, please allow me to present my experience and proposal for research and teaching for possible faculty post application at University of Chile. I am Aniruddha Chandra and I am currently serving as an assistant professor in Electronics and Communication Engineering Department in National Institute of Technology, India. This is my web page address, so any further information regarding my other particulars can be accessed from this page. So today's talk has the following outline. We will be first talking about our current research, then we will be talking about our past research. After that I will be briefly mentioning my teaching experience so far, and finally I will be talking about the research and teaching proposal about University of Chile. Well, to start with the current research, first I will be talking briefly about the three directions in which we are conducting our research. These three directions are as follows. The first one is green communication, the second one is cooperative spectrum sensing, and the third one is power line communication. Now let us briefly discuss what actually the motivation is behind undertaking these research works. Well, as far as the green communication is concerned, what we are really doing is we are trying to assess the energy efficiency of relay assisted wireless systems, and we are trying to see how the relay can be used to make the wireless communication further greener, or to improve the energy efficiency of wireless communication systems employing relays further. The second topic that I will be discussing is cooperative spectrum sensing. Now, cognitive radios currently is a very hot topic, and spectrum sensing is a very intricate task for the cognitive radios. Now, what cognitive radios does, or cognitive users does, is they sense the availability of primary users, and if we can allow different cognitive users to cooperate, then this kind of sensing performance can be further improved. The third one is power line communication. Well, in power line communication channel, we have found that the background noise and impulsive noise deteriorate the performance of the digital transmissions very much. So what we are trying to do is we are characterizing the noise processes, and then trying to implement different channel coding strategies, in particular Reed Solomon and LDPC coding strategies, so that these imperfections can be mitigated to some extent. Now let us discuss each of these topics in detail. To start with the green communication. Well, this is actually a summary of what we are currently doing. The idea is to save energy by introducing a relay between a source and a destination node. You can see that we have a source here and we have a destination here, and we can put a relay in between. Now, how it can help in saving the energy? Well, we all know that the transmission power is nth varies with nth power of the distance between source and destination, and let us denote this destination by d. So we can say that the transmit power Pt is basically written as c into d to the power n, where c is basically a constant. Now, instead of transmitting directly from source to destination, if we transmit from source to relay first and then from relay to destination, and let the relative path lengths be d1 and d2, that means between source to relay the distance is d1 and relay to destination the distance is d2, then we can say that the energy that is consumed for transmission in these two hops is say pt1 and pt2, as shown here, pt1 and pt2, and they can be written as c into d to the power n and c into d2 to the power n. Of course, d is sum of d1 and d2. Now, as it is evident that this quantity d1 to the power n plus d2 to the power n should be always less than d1 plus d2 to the power whole n for any value of n that is greater than 2. it is quite evident that PT1 plus PT2 is less than PT. So the summary of this whole thing is, instead of transmitting directly from source to destination, if we can transmit first from source to relay and then from relay to destination, then the total energy consumption for the transmission is reduced. However, this calculation is oversimplistic and it does not consider the energy consumption by the circuits of the source, the destination as well as the relay. So what happens when we consider the energy that is consumed by transmission and receiver circuit? What happens when we also consider the energy that is consumed by relay? Well, in that case, whether we have at all energy saving or whether we will have more energy to spend. Well, actually through our research we found that the energy saving entirely depends on the relay placement. That is, depending on the D1 and D2, either you can have an energy saving or you might not. So what these two diagrams show here is, the first diagram is a linear placement of relay between source and destination, and we can see that the energy consumption ratio, by energy consumption ratio we mean that the energy consumed in the relayed path by energy consumed by the direct path. That means energy consumed in this path by energy consumed in this path. And you can see that when this ratio is more than 1, of course there is no energy saving. And you can find that within certain ranges of the relay we can have energy saving. And it heavily depends on the path loss exponent and other factors. Now, of course, relays are not always to be in the same line between source and destination. And in case of a two-dimensional relay placement, we can have energy saving contours. And we have shown here this green zone is actually the zone where energy saving is possible. So if the source and destination is like this, and relay can be placed on this two-dimensional area anywhere, then if it is placed only inside this green zone, then some energy saving is possible. Otherwise, there would not be any energy saving. And of course, as this is the optimum location of the relay, as we go away from this optimum location, the energy saving will be lesser. Well, the idea is extended to both linear and non-linear scenarios, and we have found the optimum location. And during this non-linear placement, actually we implemented this whole thing in the context of our own department. This diagram shows the floor plan of our department's first floor, and of course this is my cabin anyway. And what happens if we place a source here and if we place a destination here, and if we need to place a relay, where it should be placed so that energy can be saved. So we have got some contours which are shown here, and depending on where the relay is placed from this contour map, we can deduce how much energy saving is possible. The outcome of this research has been already published in one conference, and we have submitted our findings in one journal paper. Let us move on to our next topic, which is cooperative spectrum sensing. Now, as I was telling earlier, that in cooperative spectrum sensing, the primary idea of spectrum sensing is to detect the presence or absence of a primary user, and generally the commutative radios sends the primary user through an energy detector. This diagram shows the basic blocks of an energy detector, where we get some signal and we pass it through some filter, then we do a power law, we integrate it, and we decide whether there is a primary user or not. And let us denote these two cases as presence and absence of primary user as two hypotheses, H0 and H1. So of course, in case of H0 we have absence and only noise is present, whereas in case of H1, that is primary user is present, the signal from primary user is there, and it is also affected by the fading that might be present during the transmission of the signal. Well, what we are exactly doing in this domain is, we are first trying to improve the energy detector by, instead of taking a simple power square law, we are taking a power law, that is, we are raising the signal to the power p, and we have found optimum values of p where the sensing performance is best. Now, what we mean by sensing performance? By sensing performance, we mean the probability of false alarm and probability of misdetection. Now, what are they? Well, if there exists no primary user and still the cognitive radio senses a primary user, in that case, the event is called a false alarm, and it can cause poor spectrum utilization, because in that case, cognitive radio restricts itself from transmitting, although there is no primary user present. On the other hand, the misdetection event is when there is a primary user present, but the cognitive radio user fails to detect the primary user and transmits, and as a result, unnecessary interference occurs. So this is our basic system block, and what we are trying to do is not only assessing the false alarm and misdetection, but also improving these probabilities by using a cooperative rule. So instead of detecting the primary user with a single CR, we are taking help of multiple CRs and taking their signal outputs to a fusion center, where by combining the decisions of individual CRs, we can have better sensing performance. Now, in the fusion center, we are using different hard decision fusion rules like OR rule, AND rule, and majority logic rule, and we have found in different scenarios different logic performs or outperforms others. We are also considering the cognitive radios if they can be equipped with multiple antennas. What can be the scenario in that sense? Actually, the performance improves further. The corresponding publications include 2 conference papers, and we have already submitted 3 journal papers. After discussing this topic, let us move to the third topic, which we are also currently working on, and that is about call and communication. I hope you remember that we discussed about characterization and mitigation of impulse as well as background noise. So what we found from our literature study is that in power line communication, generally the AWGN or additive white Gaussian noise model does not work any longer. Rather, the background noise follows a Nakagami distributed amplitude. Also, in case of impulsive noise, Middleton's class A or Bernoulli-Weibull type of distribution can be a better fit. So we considered the background noise to be Nakagami distributed, and what we did was we calculated the performance of BFSK and CDMA in such a noise, and this diagram actually shows how we did it for BFSK, the theoretical calculation. And this diagram shows how the MFSK and DSCDMA can be compared when they are implemented in power line communication channels. Now, after going for the primary assessment, next task was to have a mitigation of this kind of noises, and we are trying 2 different codes. One is Reed-Solomon code, or RS in short. The second one is LDPC. And these 2 codes have shown great performance in mitigating this kind of noise, but the results are still waited. Meanwhile, we have got 3 conference papers, and of course we are working fast. And with this diagram, and actually finally this diagram, let me tell you a bit. This is actually the basic model how we compare the MFSK and CDMA for obtaining these graphs. Now, with this discussion, we finally come to an end to our primary research or current research topics. And next, we are going to discuss the past research. Well, I got my PhD in 2011, and during my PhD, I actually worked on fading in wireless channels. And in particular, what we did was we characterized different propagation environments, like we assessed Nakagami fading, white fading, and other kind of fading, apart from the regular Rayleigh, Raysian, etc. And we assessed the performance of different advanced digital modulation techniques including MQAM, MFSK, MPAM, etc. And then we calculated the improvements that we can have when multiple antennas can be implemented in the receiver side, which is more or less popularly known as diversity combining, and we considered various variants of this diversity combining, including the well-known selection combining, maximum ratio combining, equal gain combining. Apart from that, we have also considered relatively less studied switched combining, like switch and examine combining or switch and stay combining. The analytical calculations were validated through MATLAB simulations, and we have run extensive Monte Carlo simulations for that. These two diagrams actually show a glimpse of our earlier work. The first diagram is actually the bit error rate of simple BPSK when we use switch combining, and that performance was assessed in a double Rayleigh fading channel or a cascaded Rayleigh fading channel. On the other hand, here we show another performance, the performance of outage probability, which was done in FY fading channel. The outcome of the past research was like this. I have got my field thesis, of course, in 2011. The title of my thesis was Performance Analysis of Diversity Combining Techniques for Digital Signals in Industrial Channels. We have also got a monograph under similar title that was published in November. And the outcome was published in 11 journal papers, and there were 16 conference papers. I have published extensively with IET, like IET Communication, Electronic Networks, etc., Springer, Wiley, and IEEE Potential. Well, apart from naming the journals, I would also like to very humbly communicate to you the quality of our research work. One of our papers, which was written jointly with one of my students, was cited by McGill University Professor W.J. Gross, and actually he named an expression after us. And this paper was something like on the Chandra etc. Apart from that, I would also like to highlight our work on white fading channel. In white fading channel, actually our group was did some pioneering work in developing the cumulative distribution function. Unfortunately, there were simultaneous publications, so the credit got shared. And finally, although this was not included in my PhD thesis, this was a student project work. Well, that was done on RFID traffic control kind of thing, and that paper attracted some foreign consultancy. In particular, I would like to say about the CEO of Direct Credit Solutions, who approached us for possible implementation of that concept. Apart from the known research work, I have also tried to venture into other domains and shown a bit of adaptability as far as I could. We had collaboration with departmental colleagues, like electrical engineering colleagues, and we worked on genetic algorithm-based optimization for antenna design. We have also worked on VLSI interconnects and did some work on soft handoff in CDMA, and these are some outcomes. Well, we have got 3 journal papers and 2 conference papers out of activity. However, our work was not only included to the collaboration with departmental colleagues, rather we involved non-departmental colleagues as well. And as a result of the collaboration with civil engineering colleagues, we got some flat frequency modeling, and we have also done some tidal wave analysis. Actually, the idea was to have some statistical characterization of the flood return period, like after how many years we can expect flood, etc. So So we considered a basin and we applied some statistical model. And we are preparing one journal paper on that. And finally, we also entered into some non-engineering collaboration, and we tried to implement our statistical distribution knowledge to the pharmacy department, and we have got some drug release characteristics, and that also got some publication. Well, apart from these activities with departmental as well as non-departmental colleagues, I was also involved in some other activities like organizing conferences and seminars. We have got one conference in our institute, which was ICT, or International Conference on Emerging Trends. I worked as the publication chair there. And I was also a member of the organizing committee in international conference that held in China. I regularly go for lectures and seminars, and as a result I was invited by one IEEE international conference to deliver the keynote lecture. This is actually corresponding conference one. And we have also, I have also delivered tutorials in some other conferences, as well as I have delivered a IEEE course of lecture. Currently I am serving on the editorial board of 3 less popular journals, and I have got some professional membership as well, and I like to review as well, and I regularly work as a reviewer for IEEE and IEEE or Elsevier or YD journals, and also I had some experience in as an external examiner. So this was all about our current and past research activities of our group, and now let me discuss a bit of the teaching experience I had. Well, in my teaching career, actually I taught in 3 different institutions, including this one. So first let me talk about what I did in these 3 institutions. Well, my present institution is National Institute of Technology, where I am serving as an assistant professor from 2005, and I am regularly teaching postgraduate as well as undergraduate courses. I took information and coding theory courses, random process courses, combination network courses, and so on. During 2011 to 12, I was also a visiting professor at Asian Institute of Technology, Bangkok, where I taught a postgraduate course called Teletropic Engineering. And prior to that, I worked as a visiting lecturer between 2004 to 2005. And in that institute, I had some experience in undergraduate teaching, like courses like digital signal processing or analog circuits. In my current institutions, apart from teaching, I am also involved in some other activities, like we are regularly developing laboratories. Specifically, I was involved in design and simulation laboratory, as well as other communication laboratories, and we also need to guide or supervise master's, PhD, as well as undergraduate projects. Currently there are 3 doctoral students, 13 master students have completed their thesis, and 4 master students are working, and there are 3 undergraduate projects also working as well. And as a faculty advisor, I love to associate it with various student activities. So I am currently faculty advisor of 3 student clubs. One is the IEEE Students Branch. Actually, I was a founding member of that in this institution. And I have also keen interest in Maths and Tech Club and also the Robotics Group. And this is actually a robot that was made for the Robocon 2010 competition by our students. There are, of course, some administrative duties as well. Like I acted as a postgraduate coordinator between 2007 and 2009. Well, in teaching, of course, communication skill is a very key issue, and in that sense, I would like to highlight 2 points. The first one is the certification that I got from a National English Language Test, and the second one that was from my thesis report. Well, Professor Ian Glover was my thesis examiner from UK, and he very kindly gave his comment that the literary presentation of the thesis is excellent. So I hope, as far as English is concerned, my communication skills are up to the mark. And finally, the teaching philosophy generally that I follow. Well, as far as the undergraduate courses or pre-graduate courses are meant, in that case, depth matters less than the breadth, and I would like to have hands-on experience so that whenever they join the industry, they can implement the concepts they have learned here. And during one of my courses, telecommunication networks, actually I made it mandatory that how our own telephone exchange as well as how our own computer servers work and how this network is maintained in our institute. On the other hand, in the master's level, I always believed that these are preludes to the future research work, and that's why I seldom follow textbooks and rely more on research papers. Finally, I am coming to the research and teaching proposal for the University of Chile, and at first I will be talking about the research possibilities when if I can join this institute. Well, I'll try to collaborate first within the university itself, and the first task to collaborate will be to find a particular group which has the same interest in which I have expertise. And I hope, I'm sorry, due to my poor knowledge of Spanish, I might have done some mistake, but probably this is the group which is working in my area, and I hope to induce some new doctoral candidates into this group, and probably we can have some joint work. Also, I would like to maintain my existing collaborations. Currently, we are having collaborations with 3 different institutes. One is in Brazil, and we are also actually working on energy efficiency or green communication with our Professor Souza. And Professor Prokes from Czech Republic, we are trying to implement some localization techniques with ultra-wideband, and with Professor Lubex in Belgium, actually we are trying to implement some filter bank based modulation techniques which can be implemented in professional mobile radios or PMRs like the Tetra system, which is more or less popular. And of course, a key issue will be to maintain the collaboration with my own home country, so I can be always in touch with my former colleagues, my students and my research associates, and that can I can pursue the current research out there with their help. And finally, as I was saying, that probably it's a good time to start learning Spanish so that I can sustain out there. Well, this is my teaching proposal for University of Chile in the undergraduate level. I have identified 2 programs probably that are being run in the electrical engineering department in the pre-graduate level, and I hope to teach the existing courses on information, communication, signal systems, etc. like this. And there are a lot of things. Of course, actually I found a lot of courses, and I am also thinking about introduce some new courses. However, I am not sure whether the course structure can be entirely changed or not. So if the course structure cannot be changed, I can teach some existing courses, and side by side I can offer some new electives. And there are two electives in my mind. One is telecommunication networks, where we will be talking about other than computer and telephone networks, like what can be a satellite network, what can be an optical network, and a preliminary idea of all those networks. The second elective is a bit more specific, which is the principle of simulation. Well, in communication as well as in other areas, we currently have a widespread use of simulation, and MATLAB and other kind of softwares are heavily used for this. So we can have a preliminary idea of basic MATLAB, and then how communication as well as control, circuit and other kind of theories can be explained with the help of simulation. So a course can be offered on the principles of simulation. So this is the proposal for the undergraduate level, and next we are going to discuss the proposal for the postgraduate. In the postgraduate level, this is the program that is offered by University of Chile, and of course there are some existing courses that I can teach, like the principles of communication and so on. But I am also thinking about, actually in case of masters we have more flexibility, so probably changing the course structure is a bit feasible, and I have seen that there are some changes being made. So I hope to introduce some new courses at master's level. The first one might be teletraffic engineering, which I already taught in Asian Institute of Technology, Bangkok. And we can also discuss queuing theory along with the theory as well as simulation part. The third course I am thinking about introducing is advanced digital communication, where we will be talking about advanced modulation techniques, like the hybrid modulation techniques as QAM and its various variants, like star QAM and so on. Also we can include the spread spectrum concepts out here, and other component of this communication course can be advanced coding theories, like the turbo coding or trellis coding, etc. The turbo coding is practically very interesting nowadays, as it is the Shannon limit reaching code. So we can have an amalgamation of these concepts in this course. And finally, we can also have a simulation course for the master's level, but it can be more precise and focused on communication systems. Like we can have a simulation of communication systems where we can describe how we are going to simulate an MM1 queue, for example, or maybe a basic multiple access mechanism like CSMA or Aloha, or how we can simulate an automatic repeat request technology, or even further how we can simulate multiple antenna techniques or MIMO and so on. Well, these are the proposal for undergraduate and master's level. And finally, I am coming to the end of my presentation by giving answer to some key questions. I am grateful to Professor Bekanayuma for raising these questions. Well, the first question is about when I can start. The normal notice period in our institution is 3 months. And of course, it requires some time for visa and other kind of processes. And the second question is, what about my PhD students? Well, of course, they are not going to finish by the time I am going to join, but they will be registered with a co-guide. So, as far as their degree is concerned, there will be no harm. However, as far as the guidance is concerned, I will try to be in constant touch and have the research going on. Earlier, that mode was a bit successful when I was in Thailand for 6 months, and at that time, this kind of distant communication was still beneficial. So with this, I end my presentation, and thank you all for a patient listening. And if you have any comments or questions, please mail me in this mail ID. My mail ID is aniruddha.chandra@ieee.org, and I will be happy enough to answer you.